Hello, and welcome to Silverline API. Today, we'll be creating a secure, API-driven attendance tracking system for groups managing volunteers. The system will feature a volunteer sign-up API, a volunteer login API, and an attendance submission API. Notably, the attendance submission API will require JWT bearer token authentication. From a technology stack perspective, we'll be connecting to an external Supabase database, which is essentially a PostgreSDB. This will help us manage volunteer details, including usernames, hashed passwords, and attendance. We'll ensure password security using SHA-2 hashing, and the attendance tracking API will be authenticated using JWT tokens. Let's dive into building our Signup API. For this API, volunteers will register by providing their name, email, and password, which will securely save in a database using SHA-2 hashing. Upon a successful sign-up, the API will return the newly created volunteer IDs. Ensure that once you log into the Silverline API application, the volunteer database is connected to your data sources. Navigate to the Data Sources tab. Here, you can either connect to an existing list of data sources or create a new data source. Just enter the necessary connection details and follow the prompts to save this data source. Next, head back to the APIs tab and click on the New API button. Select the relevant data source, which in our case is volunteers. It's time to assign a name to this API. Let's call it the Volunteer Signup API. During the query creation step, you have the choice of manually writing the query or using Silverline API's AI assistant. To take advantage of the AI, simply describe your requirements in natural language. I'm going to use the AI to help build my query. Here's my natural language request. I'll write a query to insert a new volunteer with specific parameters: username, email, and password, formatted accordingly. Silverline API utilizes parameters, which are called using a specific format. The format involves two open curly braces, the parameter name, and two closed curly braces. Additionally, I'm asking the AI to apply SHA-2 hashing to the passwords we'll be inserting. Great! Let's quickly test this. Enter a username. Now enter an email address. Let's add a password. Perfect. It looks like our insert operation was successful. Now we also need the system to return the newly created volunteer ID once the insert is successful. We can continue the conversation with our AI to achieve this, asking it to return the new volunteer's ID. Awesome, the query is now built for us. Let's test it once more. Perfect. We now have a volunteer ID that's been returned. Now, let's move on to the script setup. We'll specify that if the returned volunteer ID isn't a positive number, it should return a negative one. This acts as a safety net for potential issues. To build this, we can either manually write a Python script or use our AI assistant for assistance. What we have here is if the query result set, the parameter we'll use to bring data from our query into our script, doesn't contain a value greater than 0 for the volunteer ID attribute, then it should return the volunteer ID attribute as -1. Here's the script, which was conveniently built for us. One critical aspect is ensuring that variables used for the query result set are formatted exactly as two open curly braces, the words query result set, and two closed curly braces. I see just one here, so I'll correct it to 2, and then we'll run the script. As you can see, the value returned is 68. Now let's test if everything works as expected. I'm going to return to my query setup. I'm going to run my dataset using previous values. I believe it's email 3. I'm attempting to create an error. Excellent. You can see a duplicate error here. In this situation, our script should return a -1. You'll notice this error from the previous screen, and it's saved in our parameter queried result set. Upon running this, you'll see the volunteer ID returned as -1. Perfect. We can now confirm whether our insert was successful or if an error was encountered. There are multiple ways to achieve this using just the query, but I wanted to demonstrate how a script can work in tandem with the query. Once this process is completed, simply click on Save. Now, let's navigate to our API access control settings. Ensure that it's configured for API key-based authentication, and once you've set that up, click on Publish. Your endpoint is now ready to go. We can also assign a friendly name to this endpoint by going into the optional settings. And you can simply type volunteer signup and submit the form. Next, let's go ahead and copy our endpoint. We'll do a quick test using the username 4, email email4@example.com, and password 4. We received the expected response confirming everything works. If we try running this again, it throws an error due to a duplicate entry. And that wraps up our endpoint setup. This endpoint can now be used from any external application with these parameters to sign up. All right, let's move on to the next step, which is user authentication. In this step, we will build the user authentication or login API. Volunteers will log in using their registered email and password. If the authentication is successful, the API will return an authentication token and volunteer ID. If the login attempt fails, the API will return a volunteer ID with a value of -1. To create this API, navigate to the APIs tab as before, click the New API button, and select a data source. Ensure that you check the box labeled, "Are you creating a login API?" This indicates that the API must return a JWT-signed token. The token is valid for 3 hours for the free tier, but the paid tiers offer greater control over token expiration and other settings. You can write the query manually or use natural language. In this case, we'll instruct, write a login query to authenticate users against the volunteers table by matching the provided username and password. The password should be hashed using SHA-2 before comparison. Remember, during signup, we used SHA-2 for password hashing. If authentication is successful, it returns the corresponding volunteer ID. Let's perform a quick test to see if everything works as expected. Great! We got a response with the volunteer ID 45. Now let's add an additional action to this query. We'll specify, if the comparison fails, return a volunteer ID with a value of -1. This updates the query, so let's test it again. It will return the volunteer ID if it matches, and if it doesn't match, it returns a -1 for the volunteer ID. For an authentication API with users stored in an external database, we need to assign them groups for access control. When users access protected APIs, their requests are validated against these groups, permitting access only to authorized users. To achieve this, each user is assigned a group using the Silverline groups parameter for authentication. Just as a reminder, we can utilize natural language to ask our query, if the comparison is successful, return a field called Silverline groups with the value team volunteers. This group assignment will be used for other APIs validation against protected access. In case the comparison fails, it should return the volunteer ID as -1, along with the Silverline groups parameter set to auth failed. All right, let's give it another try. Perfect. The Silverline groups returns team volunteers. Now let's test what happens if for some reason it fails. As expected, the group returned is auth fail, indicating validation failure. Now let's name this API. We can name and save this API at this point. We'll also go to the optional settings to provide a friendly name for the root and then return to the API endpoint. Before publishing, let's run a quick test to ensure everything is functioning properly. This is a post method API, so we'll run another quick test. As we can see, the response includes a valid volunteer ID, associated groups, and our authentication token, which will be used in subsequent API calls. Let's consider an example with an incorrect username. The response shows a volunteer ID of -1 and auth failed in the group parameter, allowing us to manage API call status on the front end. Lastly, click on Publish. And there you have it. The API is ready for use, allowing us to authenticate logins. Next up, we're building the attendance submission API. After authentication, volunteers can submit attendance by providing their authentication token, which includes the volunteer ID as a claim. The API will validate the token before recording attendance. Upon successful attendance recording, the API will respond with a newly created attendance ID. To mark attendance, the query inserts a record with the volunteer ID and status as present, and it returns the new attendance ID after insertion. To construct this API endpoint, navigate to the APIs tab, click on the New API button, select the data source, and click OK. From here, you have the option to write the query manually or use natural language to create it. So I'm asking the AI assistant to write a query to record attendance for volunteer ID. In this case, I'm using the parameter token.volunteerid, which has volunteer ID as a claim of the incoming JWT token. The format for this is 2 open curly braces with the word token, then dot, and then the parameter name, volunteer ID, and 2 closing curly braces. We want to mark this attendance status as present. After inserting the record, retrieve the newly generated attendance ID. All right, let's give this a try. Enter a sample value that your incoming token might contain. Here is the response containing the newly generated attendance ID. Let's give this API a name and save it as a draft. It wants me to execute this. I'll just give it another try. As you can see, I just executed this, and now I can save this as a draft before publishing it. I can also assign a friendly name to this API route. Let's go back to our API endpoint tab here, and we can publish this API. There you go. Our API is ready. But one thing here that we have to make sure is the groups. Let's ensure this API validates incoming requests based on assigned groups. In the login API that we built a little earlier, users were assigned to the Team Volunteers group in the Silverline groups parameter. To make sure access is restricted to only those belonging to this group, go to the API Access Control tab. And the Groups tab in here. And at this point, we can add a group. Click on Add Group, select the groups from the drop-down, Team Volunteers, and save. What we just did was we forced this API to only accept requests from those users who belong to the Team Volunteers group. The JWT token we created in the Login API has this in its claims. So first, a token gets authenticated to make sure it's a valid token, and then it checks for the group. And if it belongs to this group, then access is granted. As you can see here under the API Access Control tab, the authentication we have set up is JWT bearer token, and we've allowed the Team Volunteers group here. With that set up, now this API is ready to be consumed. This is our API endpoint. Before running tests for the 3 APIs we've just created, let's take a moment to understand the process of adding groups within Silverline API. As you can see here, we added the Team Volunteers group to our API endpoint. That is the volunteer attendance. To add this group, go to Users and Groups, select Groups here, and I've already added Team Volunteers, but you can always add a new group by just clicking on New Groups, and that's it. All right, let's run some final tests here. For all the 3 APIs that we just built, let's go ahead and run them one after the other. Let's see what the results look like. I will be using curl here to test them, but these APIs could be run from any front end or any other tool that you would be using. This is the first API here that we built, the volunteer signup. In this case, as you can see, this is our API. I'm going to send a curl request using the post method, with the header's content type being application/JSON, and the data that I'm going to send is a username, that's username1, and an email, email1@example.com. So this is signing up with the Volunteer Signup API. Once we have this information here, let's just run this. As you can see, we successfully inserted the information and the volunteer ID was returned to us. Next up, we can run our second API, which is the Volunteer Login API. This is the Login API. In this case, again, I'm sending my content type as application JSON, and to log in here, I'm going to send the sign-up information that I just ran, and we should be returned with the ID and the token. There you go. We got the volunteer ID back. We also got the group. If you recall, in the Login API, we assigned each user to a group, the team volunteer, and we were also returned with the token here. So this is our token. This way, we have the information we need. Now, the final API that we just built was the actual attendance submission. So let's go ahead and run the attendance submission API now. This is our actual attendance submission API. We are sending as part of a header here the token that we just received in the previous API call. We'll use that here. Let's go ahead and send this information. We received the newly generated attendance ID here, confirming our attendance was successfully recorded. This way, we can run our APIs using different front ends or tools, and it's that simple to start and build APIs. Thank you so much for your time today, and thank you for watching this demonstration. If you'd like to explore further, find more helpful videos, or access detailed documentation, please visit our website at www.silverlineapi.com. We look forward to supporting you as you build faster, simpler, and more powerful APIs with Silverline API.